Awesome. Well, good afternoon, everybody. Thanks for inviting me here. Really excited to be talking to you. Apologies if I'm a little bit nervous. Normally, when I do presentations, I'm at home in my pajamas with the camera off. So they've asked me to actually put clothes on today. Also, as well, at 4 a.m. this morning, I was in a taxi heading to the airport in London. So let's just try and work with it. And if anyone else is falling asleep when I talk, I understand perfectly. So the question that was asked earlier: who's heard of HashiCorp? Yeah, quite a few people. Who's heard of Terraform? Yeah, sort of similar number of people. Occasionally when I ask this question, who's heard of HashiCorp, they're like, oh, no, not really. And then they're like, oh, wait, you're the Vagrant guys, or you're the Terraform guys, or you're the Console guys. So we've actually got a series of products. I've got them across my shirt here. So you might actually know Terraform for one of these different things. So first things first, who am I? I'm that handsome chap at the top there. I'm Russ Parsloe. I'm a solutions engineer for HashiCorp. I'm actually based in the UK. We've got a wonderful team based here in Germany. We've got Christoph, we've actually got Thomas, we've actually got another couple of people who've actually joined since I put these slides together recently. And of course, we've got 4 people in the country, all speak German, so they asked the English guy to come and do a talk to you all, so apologies for that. So at HashiCorp, we basically believe there are 4 elements of dynamic infrastructure. And I'm going to cover actually 2 of those today, one in a talk right now, which is the bottom bit, the operations bit, where we actually provision infrastructure. I'm going to give a talk a little bit later, so if you liked this one, hopefully you'll listen to the next one as well, which is around our security product, which is Vault. Our development layer, which is a scheduler we have called Nomad, and then the kind of thing that bridges all these things and connects them all together is something called Console, which is the C here. If you're interested in any of the other 2 things that I'm not going to talk about, come and find us at some point. I'm happy to have a conversation about them. So the thing I'm going to talk today is Terraform. Now, very kindly, Terraform's already actually been mentioned a little bit. But again, let me just sort of give a view of the world. So if I was to look back when I started my career in IT, like a couple of years ago, because I'm still very, very young, it was very static. It was all about, you had a data center and you had some physical machines in there. Maybe like when I started, things were like virtualization was just starting to become popular, but it was very static. It didn't change an awful lot. Like even large organizations had their data center. It was all on-premise. They put big arms around it, and they managed everything inside their data center. And of course, Amazon and Google and Azure and Alibaba and IBM and Red Hat and all these other people came along and went, do you know what, there's a different way that people want to consume these services. So we're moving away from having very static, steady, doesn't change very much infrastructure to changes every day, every second, every minute. People are making dozens, tens, thousands of deployments every single day. Now, the problem with the traditional approach was it was always very manual. You know, everything was done one at a time. I used to be a Windows Server engineer, and when I wanted to do something to 10 servers at once, I logged into each server one by one and try and reproduce all of the different steps on each of the different servers, and it didn't really work. Things were very similar though. You know, I didn't have lots of different types of technology. I just had Windows servers, which was kind of a little bit boring. We moved to the cloud world, it's like, what do you want? Like, how many new services has AWS released today? Probably like 7 in the time that I've actually been talking. But the trouble with that is we introduce a lot of complexity. So all of these new different technologies that we're adding and introducing, we have to be able to manage them. So if we look back years ago, it was hard because we were doing things manually. You'd think by the time we got to today, everything would be easy, but it's not, because we've got all these different services and it's introduced new complexities. So Terraform's trying to solve that. There's kind of lots of use cases for Terraform, but the 3 main ones I want to talk about today are infrastructure as code. Has anybody heard the term infrastructure as code before? Ah, slowly, hands are going up, hands are going up. Multi-cloud management as well. We say multi-cloud, but I think a better way of describing this is probably like multi-API, actually. So when we talk about clouds, I'm not just limiting ourselves to the 5, 6 sort of main public clouds. It's all of the different types of technology that you need to manage to deliver your infrastructure so you can deliver your applications to your users. And the other great use case of Terraform is self-service infrastructure as well. So it would be great if everyone in the world was an expert on Terraform, and that's a lovely dream, but I know that's probably not really going to happen. However, the benefits of Terraform you want to be able to offer to as many people as you possibly can. All of your different application teams, development teams, network teams, for example, are going to want to leverage Terraform as well. So I'm going to talk about a few of the principles of Terraform, and actually of HashiCorp. Actually, HashiCorp ourselves, we have something called the Tower of HashiCorp, and there's a series of principles. You can look at them on the website. They're quite interesting to read. But one of those is automation through codification. So if I look at how infrastructure used to be years ago, it used to be very much, there was a GUI, you'd click a button a few times and you'd get some infrastructure. Well, because we're managing things at such massive scale, that doesn't really work. We can't operate those things at such large scale. But if we can actually codify our infrastructure, I mean, we've been able to codify our applications for many years. Wouldn't it be great if we could do the same with our infrastructure? We could put it through the same processes, through the same testing. We could put it into version control. We could do unit testing. We can do pull requests, peer reviews, and all the great things that we've been doing with applications. But now we can do it with our infrastructure as well. And I don't know how well you can see this diagram. It's probably not, the image is probably not very clear, particularly from the back. But this is actually an example of some Terraform code. And how many people haven't seen Terraform before? Let me ask that question. Who's not seen any Terraform before? Okay, I'm not going to pick on somebody, but if I wanted to, you could come up here and look at this, and you could just read it, and you probably know what it is that this is actually doing. It's pretty human readable and simple to understand. Another one of the key principles about Terraform, and again about all HashiCorp products, is workflows, not technology. And why is this important? Well, again, talking about my journey through my career, it used to be physical machines, and then virtualization came along, and everything became virtualized. Now we're moving to containers, and everything's maybe going to get to containers at some point in time. It's still quite low, but eventually maybe everything will move to containers. There's going to be a talk in the moment about maybe serverless or functions as a service. We're going to, again, keep moving the technology all of the time. However, we focus on the workflow. So the workflow itself isn't really going to change, and as new technologies come along, we want them to be able to fit inside of the workflow that Terraform provides. So it's a very consistent workflow. Terraform's also very open and extensible. I think one of the reasons that Terraform has been so successful is it's not essentially trying to get everything into the core products as much as possible. We have a core, which is how Terraform actually works, and we have all of these providers that will actually utilize that core to be able to provision infrastructure. So we've got some examples on here: Azure, AWS, Google, VMware, Alibaba, Oracle, etc. And that's just 8. There's like another 150, probably more than 150. They're actually of different types of technologies that you can actually manage with Terraform. So just very briefly, I'm going to go over how Terraform works. So essentially we have this, the core engine of Terraform, and that's responsible for a number of different things. It basically takes some of those files. I gave you a very simple example of one of those files earlier. And obviously you're going to have maybe not just one virtual machine, you're going to have 5,000, and you're going to have load balancers, and you're going to have storage, you're going to have S3 buckets, and all the wonderful things that the cloud provides. The core is responsible for taking all of those files, bringing them all together, and basically compiling them such that it's going to build a graph, and I'm going to talk about that in a little moment as well. It's also responsible for communicating with those providers, and I said there are many different providers, all the different types of technology, so it's not just infrastructure, it's your platforms, it's your software as a service, managing your Git account, managing Datadog, managing your CDN, whatever it may be. You can codify all of these things with Terraform and then easily provision them. One of the great things about Terraform as well is when I basically say to it, here is my entire infrastructure. I'm not just talking about a component. This is my entire application. However many different components it actually has, we need to actually provision them. Now, one of the things that we know is there are dependencies. So, for example, if I wanted to provision a virtual machine and I wanted to put it on a network, the network needs to come first, right? I can't put a virtual machine on a network that doesn't exist, so I need to know the order in which things are actually deployed. And that's what Terraform does with the resource graph. It compiles all of these different pieces together. It knows which order things need to be deployed. Where possible, it will do things in parallel. It will try and provision as quickly as possible, but it's also intelligent enough to know that certain dependencies are required before it provisions a different resource. And the provider plugins as well. So there's sort of a whole list on the website of all the different provider plugins, not just the clouds. We talk a lot about the clouds, but that's only like 4 of all the different providers that are actually available. Plus, because it's so extensible, so many organizations I've been to have some weird esoteric system that only exists inside that organization. They've actually written providers, Terraform providers for their own systems. So it's not just the big names that you've heard of in the commercial systems. People are actually using this for their own internal systems as well, because it gives them the consistent workflow, regardless of what the technology is. So I'm going to talk about the first use case, which is infrastructure as code. So again, one of the challenges that we used to have was everything was point and click. Again, I can say this because I used to be a Windows Server engineer. Like the command line used to scare me. If I couldn't click a button, I didn't know what to do. And it made things very challenging, shall we say. The trouble is that doing things manually is very error-prone. I'm terribly error-prone. I make mistakes all the time. I type 100 when I should have typed 10, for example. I miscode something, I click the wrong thing, I forget to do things in the right order, and then the dependencies don't work, and all those kind of things. So we know it doesn't work. We know trying to do everything manually doesn't really work. So the idea is, if we're using something as infrastructure as code, define my entire application stack inside a Terraform code and be able to provision it, and change it over time as well. I guess that's the other thing to mention is, it's not just a case of, well, provision this infrastructure and then walk away. Wouldn't that be great if we could just provision infrastructure and then forget about it and it just looked after itself? But we can't do that. We're engineers and we have to maintain this kind of thing over time. So we need a way to be able to do this kind of thing at scale, be able to manage it over a period of time, make changes where we need to, add new systems, remove systems. Maybe I need to scale up. I need 100 VMs instead of 10. I need to reconfigure load balancers. There's a new service that Azure have just introduced. Wouldn't it be great if we could use that as well? You can do all of those things by codifying it. Reduce the risks as well. The idea is it's very repeatable. You write your Terraform code, you run it once, it does something, you run it again, it does exactly the same thing. You run it another 100 times, it does exactly the same thing every single time. PayPal. Has anybody heard of PayPal? Yeah. So PayPal were very concerned about vendor lock-in. We sort of mentioned vendor lock-in a couple of times, and they wanted to move away from AWS to GCP, because as you rightly said, they were like, hey, would you like to use our services? We've got a very special price. Would you like to use it? And of course they did. Why wouldn't they? And if they were using, for example, the AWS native tools, it would have been very difficult for them to move across. Because they were using Terraform, it gave them that consistent workflow, so they could use it on AWS in the same way they could use it on GCP. If Microsoft come knocking on the door and say, hey, you should use our services, great. Alibaba, AliCloud is massive. I didn't realize, must have been asleep when all of a sudden they just came from nowhere, and they're like the 4th biggest cloud provider in the world. Like PayPal are doing this at scale as well. It's not just 5 people in a dark room who are provisioning all of their infrastructure, as you can probably imagine. They've got literally thousands of engineers, 100,000 VMs. That's impossible. You do the maths, I can't do the maths, somebody could do it for me. But that would be pretty much impossible to do any of that manually. They're doing 15,000 builds a day. It's absolutely huge. And so they're actually using Terraform to actually leverage all of their infrastructure and actually provision it into GCP. And there's a really great keynote that they actually did at HashiConf 2016. We'll get the link for this and take a look at that. So some of the features, and I'll show you some of this. This is why I'm going super fast, because I want to get to the demo, because slides are boring and it makes me fall asleep. But some of the features that we have is things like integration with VCS. All of your code should exist inside of VCS, because we can track changes over time, we can do pull requests, we can do peer review, and all that kind of stuff. There's things like secure variable management we have inside of Terraform as well. Because one of the problems that we were seeing with organizations was they wanted to provision into clouds, so what they did was they gave all of their developers credentials to the clouds. Now, that was probably a bad idea. You can imagine that maybe people went into the clouds and did things outside of the proper workflow, or here's a great experiment. Don't do this, by the way, I need to put that disclaimer. Get some credentials for one of your cloud providers and commit them to a Git repository on the internet. It's really funny, because then you get a Bitcoin mining farm. I mean, 100,000 probably a bit expensive, but certainly $7,000, $8,000 will be gone like that. Really great thought experiment to do. So one of the things we have inside of Terraform Enterprise is sort of secure variable management. You still need credentials to provision into the cloud, but we can secure them inside of Terraform such that they don't leak. Multi-cloud management. Again, vendor lock-in. Nobody wants vendor lock-in. People want to be able to move their workloads to wherever it makes sense to move their workloads. The trouble is everyone's probably got a multi-cloud strategy. People are going to be using multiple different clouds, but because they're all different, you have to apply different rules to each one. The workload they have for one doesn't really fit another if you're not using something like Terraform. You have to govern each one separately as well. Like, how do you control all these different things if they're all different? What if all of a sudden somebody like, I don't know, IBM or Red Hat, then all of a sudden you've got another massive cloud provider that's probably going to start climbing up the charts as well soon. So again, the solution is to use something like Terraform. You can reduce your costs because you're not over-provisioning. You don't have any vendor lock-in. If you want to move between the different clouds, you can absolutely do that. You have a consistent workflow. So again, as new things come on board, like again, I joke about it, but AWS do introduce new services quite rapidly. If you want to leverage those services, they're going to be inside of the Terraform provider, so you can use them. You can go through the same workflow. Marriott, for example, they had their reservation system in North America, and they wanted to replicate that inside of China as well, and they wanted to put that in Alibaba. And because they were using Terraform, it was a pretty consistent workflow, so they were actually able to move. I think they actually did it ahead of time, which is always shocking when a project finishes ahead of time. Let's skip some of this. So again, it's that consistent workflow, all of the different technologies, it's going to be the same regardless of what you use. I showed an example of some Terraform code. I won't show you loads of examples of code, but it's easy. You can look at it and you'll be like, hey, I've never used this service before, but even I can read what it says on the screen. It's pretty easy to do. Versus, if you do that on one of the cloud native tools, like, who's a fan of writing JSON? Good, no one put the hand up, correct answer. It's horrible, don't do it. Whereas something human readable like the HashiCorp language that we use is much simpler to actually use as well. Self-service. So, as I said, it would be fantastic if every single person knew how to use Terraform and could just write their own Terraform code. But we've all got other things to do. We're all busy, right? And you know there's going to be a core team of people who are going to be really good at Terraform. Wouldn't it be great if we could leverage their skills to the rest of the organization? Good idea. So we have something called the private module registry inside of Terraform Enterprise, which basically allows you to have your experts, your center of excellence, if I can call it that, where people write these modules and they can be leveraged by anybody. And I'll actually show this in the demo how easy it is. If you can sort of click a button, then it's pretty easy to use, and even I can use it, so it must be simple. Barclays, probably everyone's heard of Barclays. Barclays are a big user of Terraform Enterprise. They've got, I think, 15,000 developers who are actually using this to provision at like hyperscale, as you can probably imagine. And basically what they did is, it's kind of at the center of their deployment strategy. So because it's at the center of their deployment strategy, they've got a single point where they can introduce control and introduce governance over the whole provisioning process. Yada, yada. So in Terraform Enterprise, we have the private module registry. We have something called the configuration designer, which is where you can click a few buttons. It gives you some Terraform code, and then the hardest bit is probably copy and paste, which again, I'm pretty good at doing. Terraform Enterprise has a full API. Now, I talk about UIs and they don't really scale, and it's true. I like UIs because I'm a Windows engineer. However, we know that like in the enterprise, you want to automate this. You've probably got your own CI/CD platform, Jenkins, or whatever it may be, and you want to actually integrate that with Terraform. Well, great, there's a full RESTful API. You can integrate anything with Terraform quite easily. Audit logging as well. It's very important to keep a log of what people are doing, I think, particularly if you ever need to go back in time and check what actually happened. So that's something we have as well. And just quickly, before I actually go on to the demo and maybe talk about some questions as well, is like, a lot of people put their hand up when I talked about Terraform, but like really, how popular is Terraform? It's been around for quite a few years. It's got quite a large number of contributors, more than like Apache Spark, for example, which has like 1,100. That number's actually probably gone up as well. More than 150 providers, so those are all the different types of technology that you can integrate with Terraform, your AWS, your Azures, your Datadogs, your Fastly's, your whatever it may be. There's actually a typo on this screen. It says downloads weekly, 20,000. It's actually 40,000, about 40,000, 50,000 downloads, new downloads per week. So not like people updating things like that, like net new updates. So it's growing at a massive hyperscale. I will say this, I'm biased, but like when I talk to people and I'm like, well, if you don't use Terraform, which has all of this breadth, what are you going to use? And they're like, I can't think of anything else that has that kind of breadth of technology that it actually works with. So it's really super popular. And we've got over, again, that number's slightly out of date. I think that's close to about 350 now. Large customers like the Barclays, the PayPals, and all those people in the world who are actually using Terraform Enterprise as well. I'm bored of slides. Who wants to see a demo? Yeah? Right. I might need some technical assistance with this. Ironically, this is a Windows PC, and I used to be a Windows engineer. I've been using a Mac for about 3.5 years. I've completely forgotten how to use Windows, so let's see if I can get this. There we go. Yes, I think this is okay. So apologies. I can't see on here what is up there, so I'm going to have to do this. So this is Terraform Enterprise. This is the UI. There's a full API as well inside of the product. So if you're a person who likes to automate all these different types of things, then that's absolutely possible to do. So the first thing I wanted to show is the private module registry. So this is the place where you can publish modules, as I mentioned, that become your center of excellence, so that not everybody has to be an expert on Terraform. Now, let me show you an example of how that works. So I've actually got a couple of modules that I've actually published here. I don't know, who's your favorite cloud provider? Does anyone use Azure in here? One person. Picked the wrong one. But whatever, the workflow's consistent. Remember what I said? Like, the workflow's going to be the same. I did this the other day with somebody, and they were like, yeah, how does it work when you provision a database? I'm like, the workflow's the same. Yeah, how does it work when you provision a load balancer? So what I'm going to do now is I'm going to use this button up here called the design configuration. So I actually now imagine that I know nothing about Terraform. Some people would say that's not far from the truth. But I want to actually deploy my application. I've got an application I want to run. And I don't really know Terraform, but I do know that I need a network and I need some compute. I'm smart enough to know that. So I click Add Module, and I click Next. Actually, I should have picked on somebody to come and do this for me. Location, I'm going to choose West Europe. Seems good. So basically, I provide to the module, the way that a module essentially works is, a module is almost like a black box. You write a module. Smart people write modules, and then you provide inputs to those modules, like this list of things here. They go into the module, magic happens, and then you get some outputs. Hopefully you're going to get a network at the end of it. But there's some things that I can actually configure here, such as, again, the location. Maybe I want to provide my own DNS servers, or I can just use the ones that are actually part of the module as well. Now I'm going to configure the compute. I feel silly doing this, because you see how simple it is. Okay, I also want to put this in West Europe because I'm not crazy. But now I've got a bit of a problem now. So to put this compute on the network, I need the VNet subnet ID, but I don't know what that is. And the reason I don't know what that is because it doesn't exist yet. It only exists when it gets created by the previous step. So I'm probably stuck. However, of course, I'm not. Because, and I need to find where the characters are on this German keyboard, and I can't. Okay, I can't do it because I can't. Okay, where's the curly brace? The curly, here we are. This one here? Oh. Is anybody in here technical? No. Yeah, how do we do that? Which one? Ah, fantastic. Thank you. Round of applause for this gentleman. Well done. Great. Thank you. So, we shall try again. So, I need to actually get this variable from somewhere. Now, the great thing about Terraform is when a module does something, it can create some outputs. So, for example, the network module, one of the outputs it will actually create is this subnet ID. And I can take that output and use like a parameter to pass it into the compute module as an input. So I can type, whoops, told you this is difficult, module, hit dot. And I get a list of all of the different things that get output from the network module. Now the thing that I actually need is this thing down here, like so, and then curly brace, I did it. So, what will happen is, and I'm not going to pass in these optional things, what will happen is the network would get created. One of the outputs from the network would be that subnet ID. It will get passed as an input to this compute module, and the compute module will get added to the right network. And I hit next. And there's some Terraform code. Now, I want to point out something that's quite interesting about this. Can you all see this okay? Yes? No? So one of the things that's quite interesting about this is I said that I need the network to exist before the compute resource, right? But if you were to look at this, and logically, this is how we think of things, we're very procedural, is we think we start at the top and we work our way down. But Terraform's really smart. If I was to run this Terraform code, what it will actually do is it will notice the dependency I have between those two resources, and it would be smart enough to actually create the network for me first, and then it would create the compute resource afterwards and attach it to that network. It's pretty clever. Now that's a simple example, but it's also pretty boring. So let me do something a little bit more exciting. But again, I could copy and paste this, happy days. Yeah, I don't want this, it's cool. Oops. So this is like, that's the private module registry, that's your center of excellence. That's where we publish all of those different modules for people to use. But now we actually need to use these things. So the way we actually do that is, we create these things called workspaces. So let me go into one of the workspaces and actually show you what it does. So I actually did this ahead of time. I'll go to the version control here, network. So I've actually got an integration between Terraform Enterprise and my version control systems. So any GitLab users, GitHub users, Bitbucket users, maybe, no, yeah, no. Okay, so if you're one of those users, good news is you click a button within here, you start typing the name of your repository where your Terraform code actually lives, and it auto-completes for you. And then, you know, for those who are familiar with Git and familiar with branches and all that kind of stuff, we can use those within here. And I basically created this workspace. Now what this does is, it takes the code that lives inside of my version control system, and it imports it into this workspace. Now this workspace is called console guides. It's not all about products, it's the C there. And what this actually does is, it provisions a console cluster on AWS for me. There are several moving parts. There are like 3 servers for console. There's a Bastion server, there's a load balancer that gets created, a VPC that gets created, all those kind of things, security groups, yada, yada, yada. All those different things that actually make up an application. So I did this ahead of time. So what it really does doesn't matter, because the workflow is the same. I could have shown you anything, and the workflow is going to be exactly the same, regardless of what it is that I show you. So what I'm actually doing doesn't matter so much. Basically, all you need to know is, I've got some Terraform code, and it needs to do some stuff. Now, I'm at Talks4Nerds, so I actually want to run Terraform. And I'm going to hit this button that says Qplan. Now, let me explain a little bit about the way that Terraform works. So when I click that button, it's not really going to do very much. If I was to go into my AWS account and take a look, I wouldn't actually see any new infrastructure. Because all it's doing is running a plan. So it's kind of like a dry run, if you're familiar with that concept, whereby it looks at my Terraform code, brings it all together, builds that graph, knows what order it needs to do things, and then it goes, okay, I need to create these load balancers, these virtual machines, these security groups. Now let me look at AWS. And what's inside of AWS? Does any of this stuff exist? And it's smart enough to know that none of it exists. And if you can see this at the back, there are 73 resources that I actually need to add, because it's all brand new. Those 73 resources don't exist already. So it needs to create them. Now, I talked about how Terraform is actually smart, and it would know if things needed to be changed or destroyed. So imagine I deployed these 73 resources, and then all of a sudden I need to make a change to it. Then I can run this, I can modify my Terraform code, run a plan again, and it will say, hey, I need to change 3 things. Maybe I change the image that my virtual machine is actually built on. So it may actually need to destroy those things. It may say, okay, I need to destroy these virtual machines and recreate them with the new image. But it's smart enough to know what it needs to change. It's not going to blow away the whole thing if only like 3 things have changed, for example. So I need 73 resources. There's a whole list of them here. We're going to go through them one by one. No, we're not going to go through them one by one. But there's a whole list of these things here that's actually going to provision inside of AWS. Now, one of the great things about Terraform is it really does solve the challenge of provisioning at scale. But one of the things that Terraform just on its own doesn't really do is provide any controls. So I liken this to giving somebody a credit card with no limit. If you give somebody a credit card with no limit, they can buy anything. You might not actually want to do that. You want to put some sort of spending limit on, or some sort of control, really, about what it is that these people can do. So one of the things that we have inside of Terraform Enterprise is something called Sentinel. Now, Sentinel is our policy as code engine. It's actually available in all of our enterprise products, including Vault, that I'll talk about later. And for each of the products, it has a different context. Now, in the context of Terraform Enterprise, what it will actually do is, I can write a policy that specifies anything, actually. Anything that I want to control. So the example here, and apologies again if you can't quite see it, I would make it bigger, but I can't find the key I need. But I've got 2 policies. One of them is, if you can't read this says AWS instance size failed. So basically what I've tried to do is, I've tried to provision this infrastructure with the wrong size of instance. Now, the policy could have been anything. It could have been, I tried to deploy it to the wrong region, or I tried to deploy it at the wrong time of day, because You shouldn't really deploy stuff at 10 p.m. on a Friday night when everyone wants to go home. Or it may be that I needed to tag my resources or whatever. Like, whatever it is you want to do, you can write a policy around those things. But in my case, it failed on the instance size. Probably because instances can be expensive. Maybe I want to control the costs and not use the most expensive instance sizes. Now, this is kind of interesting. This is in the data path. So when I actually want to provision something, I have to use Terraform. And if this policy fails, this is a policy for my organization, so for my company, it's actually failed. So if I go down to the bottom here, the only thing I can actually do is add a comment. There's nothing within here whereby I can actually deploy this, because it's actually stopped me from doing this. So this is what you want. You want that control in an organization. If you fail the policy, guess what? You don't get to deploy your stuff. You actually need to actually adhere to the company policy. Now, how can we fix this? Because this is obviously failed and I want it to actually not fail. So what can I do? Well, there's a few things that I could actually do. One is I could change my company policy, which is probably not going to be allowed. So I'm not actually going to do that. There's a couple of other things that I could do. One is I could go into my Terraform code, which exists inside of my version control repository, and make the necessary changes to my code there. That's something that I could actually do. But I'm going to choose option 3 because it allows me to show you another feature of Terraform Enterprise. And that's the secure variable management. So if I go into here, can I make that any bigger? No? Okay, sorry, I can't zoom that in any bigger. But essentially what I have here is, I have my Terraform code, and I have certain variables that allow me to modify the behavior of how that Terraform code actually works. One of those things is the size of the instances that get spun up by that code. Now, I'm probably one of the few people that has a favorite instance size. I'm quite fond of the P3x16 large because it's the most expensive instance that AWS actually provide. So why wouldn't I? Unfortunately, my organization says I'm actually only allowed to use T2 smalls. So I'm actually going to change this now from P3x16 large, sad face, to something that I'm actually allowed to use inside my organization, which is T2 small. And I'm going to hit save on that. So now what will happen is if I queue my plan again, and I fixed my instance size, and I'm going to hit queue plan. So that's going to run through that plan again. It's going to say, okay, you need to create 73 resources, and this time, hopefully, it's going to pass the policy check. But just while it's doing that, I'm going to let that just run in the background for just 1 second. I want to show you something else, because this is kind of cool as well. So I talked about how you need credentials to actually provision into any of the cloud providers, right? Terraform still needs those. We've not got some sort of special agreement with AWS where we can just provision into AWS. We still need credentials, even Terraform needs them. So normally what you would do is you'd give those to all of your developers, and then they go crazy with them and they provision all kinds of wonderful things, or then they commit them to Git, and someone else uses your AWS keys for wonderful things. But to actually stop people from doing that is we have something called secure variable management. So I need to provide those credentials. I actually provide them as environment variables. And there's this box at the right-hand side that says sensitive. So this is actually checked at the moment. I'm doing a live demo so you can see this. I'm not actually at home in my pajamas with the camera off. So you can actually see, you can actually click this button. You can't uncheck it. So there's no way to actually retrieve those credentials back. That could be for anything, any sort of sensitive information that you need to provision infrastructure, but you don't want your whole organization to have access to it. You can actually mark it as sensitive within there, and then no one can actually read that information back. Obviously, I don't need to do that for everything. For example, the fact that it's in EU West 2 doesn't really, not really sensitive information, so I've not marked it as such. Cool, so let's go back to the run that I actually ran before, and let's just see what that looks like. Okay, so I fixed the instance size. Create 73 resources, that's the same as before, but hey, good news. I've actually passed my policy check. So that's actually worked now. So I've actually passed my organizational policies, and my organization says it's okay for me to deploy now. Now, I might just let this run in the background actually. It'll probably take longer than I've actually got left to run. I'm just going to hit confirm the plan and let that run in the background. That's going to provision my cluster of systems. One of the other things that we have inside of Terraform as well, and I've kind of touched on this a little bit, is role-based access control. Now let me give you an example of where this might be useful. You can have different teams, because you all work in different teams probably, inside of Terraform Enterprise, and you each have your own responsibilities. So for example, you may be on the network team, or the application team, or the server team, or the security team, or whatever team that you may be on. You're responsible for a certain portion of the infrastructure. Now, one of the great things is, if I just go back to the workspaces, I've got a variety of different ones here, but one of the things that I could have actually done is, for example, to deploy my console service, for example, I could have separated it out. So there was a workspace that deploys the network, and then another workspace that deploys the application on top of that. And I can give control of the network workspace to the network team, because that's their job, and then they can actually deploy it. Now, in the same way that I did with modules, remember with modules, it's like stuff from the network team is needed by another team. We can actually do that with Terraform Enterprise as well. Outputs of a workspace can be used as the inputs to another workspace for another team. So you can actually collaborate between different teams quite nicely as well. Now, it looks like my apply is going to take a little while. I know that I need to leave some time for questions and things like that. So has anyone got any questions that they want to ask about?